All right, ladies and gentlemen, let's take a look at lesson 5.4B. We're going to take a look at complex numbers. Last week we looked at, or the last lesson we looked at imaginary numbers. Now we're going to take a look at complex numbers. Don't let this fool you. They're not necessarily difficult, but what it is, the complex number is A plus BI. A is a real number, which means it can be a fraction, it can be a decimal, it can be a fraction, it can be a decimal, it can be an integer, or it can be just a whole number. All right? BI is the imaginary number part that we saw last week. And so what we're going to do today is operate with complex numbers, and then the next lesson we're going to use this idea of imaginary numbers and complex numbers to solve some more quadratic equations. So let's take a look. If we're adding or subtracting, you simply combine like terms. All right, so we're going to add real to real, imaginary to imaginary. So because it's addition, 5 plus 1 is 6. 1i minus 2i's is negative I, or negative 1i. So there's our answer. For the second one, because I'm subtracting, I'm going to change the signs and everything inside there. I'm going to distribute that negative to everything. Then we go through and combine like terms. So 3 and negative 7 is negative 4, and negative 4 plus 5 is 1. Negative 8 and negative 6i is negative 14i. Notice I'm keeping it in the form A plus BI. We take a look at our next examples. Now we're taking a look at distributing. It's just spoiling like we've done before. So 1 times 3 is 3. 1 times 5i is 5i. Negative 4i times 3 is negative 12i. And then negative 4i times 5i is negative 20. And then we have I squared. Now keep in mind, what we learned last week is that I squared equals negative 1. So this really is a positive 20. A negative times a negative is a positive. We then have like terms that we can combine. So 3 plus 20 is 23. 5i and negative 12i is negative 7i. We're going to write this out 2 times to get rid of the exponent. And we multiply. Some of you are in the really bad habit of putting addition signs. It is multiplication. So now I do 3 times 3 is 9. 3 times negative 2i is negative 6i. Negative 2i times 3 is another negative 6i. And then this is a positive 4i squared. As before, I squared still equals negative 1, so this is really negative 4 when we do a positive times a negative. These combine to give me negative 12i, and then we have the 9. Don't forget our goal would be to combine all of our like terms, so this is 5 minus 12i. So really, it's like working with our variable x like we have. The only difference we have to keep in mind is that this I squared has a specific value compared to where x squared could have any value. So I squared is this negative 1, which creates another real number for us. Here's my distributing. So this is 48i, and this is minus 66i squared. This is equal to negative 1, so this is positive 66, and we have 48i. We want to write it as a complex number, so it's A plus BI. Our imaginary number comes at the end. So now we just have some simple, or just simplifying. Distribute your negative through there, so we have 8i plus 20i squared minus 7 minus 3i. It doesn't matter where that I squared is at, that I squared is equal to a negative 1. So this is 8i minus 20 minus 7 minus 3i. Combine your like terms. We want our real numbers first, so this is negative 27. And then 8i minus 3i is a positive 5i. So notice we're not going to have any I squareds here. Everything is going to be just I, because anytime we have I squared, it simply changes the sign on our term. All right, should be a pretty easy lesson for us. We'll see you tomorrow.